Hey everyone, my name is Goransh. So today I'm going to demonstrate this task, that is repository pattern. And in this task we have several files related to repository, and the repository pattern in this task the repository pattern decouples data access uh, logic from the application layer by just centralizing functionality and providing flexibility for switching between different implementations. It also facilitates objects or object related mapping to map data between incompatible types, improving maintainability as database structure evolves. Now we'll jump to the extension methods.cs and I'll explain this. This file just validates the entity and then access the properties of type T, then extracts and stores the names of all properties of entity into a hash set, and then maps the data, iterating over each column in the npg data reader. Now we have the imap.access file. In this we have get maps. This will return the map list of maps. Then we have get map by id, driving the maps by id. Then we have add maps, adding new maps. Then we have update maps, updating the existing map. And then we have delete map, removing the map. So basically it's just accessing the map requests. Now we have the irepository.cs. In this, this file provides a generic repository pattern for interacting with the PostgreSQL database in a .NET application, allowing for querying and not modifying data in a flexible and a reusable manner. So when there is an interface iRepository, it declares two methods: execute reader. This method executes a SQL query and returns a list of objects of type T, where T is a generic type parameter. It takes SQL command, a function, to map data from an NPG SQL data reader to an object of type T, and optionally an array of NPG SQL parameter for parameterized queries. Then we have the execute non-query. This method executes a SQL command that doesn't return any result set like insert, update, or delete operations. It also optionally accepts an array of NPG SQL parameters. Then we have the class repository. It implements the repository interface. It has a constructor that makes a connection string as a parameter used for connecting to the database. It implements the methods declared in an interface. Execute reader T. It executes a query to retrieve data from a database, maps each row to an object type T using provided mapping functions, and return list of these objects. Then we have the execute non-query. It executes a non-query SQL command like we discussed earlier, that is insert, update, or delete on the database. This task is like also defining an interface, a repository, and application repository. So, yeah. Now we'll go to the other file. New file would be map repository. In this code defines a map repository class that implements the IMAP data interface, providing methods to interact with the map data stored in PostgreSQL database. So basically, first we have the namespaces you required for the code. Then we have the constructor. It takes a connection string as a parameter, allowing the repository to connect the database. Then we have the getMap method. It retrieves all the maps from the database and opens a connection to the database, executes a SQL select query to retrieve all the map records from the map table. And it maps each row of the result set to a map object and adds it to a list of maps, and then it returns the list of maps. Then we have the get maps by id int id method. In this we retrieve a specific map by using its unique id, opens a connection to database, executes a parameterized SQL query to retrieve the map record with a specified id from the map table. If a matching record is found, it creates and returns a map object with retrieved data. Otherwise, it returns obviously null. Then we have the add map method. it adds a new map to the database and opens a command connection to the database, executes a parameterized SQL insert query to insert a new map record into the map table. It sets the parameter value based on the properties of the provided map object and executes the query. Then we have the update map method. It updates an existing map in database, opens a connection to database, executing a parameterized SQL update query to update the map record in the map table with a specified ID. Then it sets the parameter values based on the properties of the provided map object and executes the query. And then we have delete map method. It deletes a map from database based on its ID, opens a connection to the database, and it executes a parameterized SQL delete query to delete the map record with the specified ID from the map table. And overall, this whole code uh, gets the logic from the create, read, update, and delete operations on the map data in the post SQL database, following the repository pattern for data accessing. And now we're gonna jump to the other file, that is robot command repository. And now I'll explain this. This code defines a robot command repository class that implements an iRobot command data access interface, providing methods to interact with robot command data stored in PostgreSQL database. Now there's a namespace is required. Then we have a constructor. It initializes the repository with an instance of repository class using the provided connection string. Then we have then we have a get robot command method. It retrieves all the robot commands from the database, construct an SQL query to select all records from the robot command table, and it uses the repository's execute reader method to execute the query and map each row to the robot command object. Then we have the get robot by id method. It retrieves a specific robot command by its unique ID identifier, that is an ID, and it constructs an SQL query within a parameterized where clause to select the record with the specific ID from the robot command table. Basically, it just selects the ID from the robot command table, and it uses the repository's execute reader method with the parameters to execute the query and map the result to a robot command object. It then returns the first command found, or if none is found, then it returns null. Then we have the create robot command, npgsql data reader dr method. It's an helper method to create a robot command object from the npgsql data reader uh, row, and it extracts values from data reader and construct a robot command object. Then we have the add robot command method. It adds a new robot command to the database, construct a SQL insert query with a parameter placeholder and array of parameters. It uses the repository's execute non-requery method to execute the query with the provided parameters. Then we have the update robot command method. It updates an existing robot command in database, construct an SQL update query with parameters, placeholder, and an array of parameters, and it uses repositories execute non-query methods to execute query when the provided data parameters. Then we have delete robot commands method. It deletes the robot command from database based on its ID and uses execute non-query method to execute a query with provided parameters. Now we jump to the file, that is iRobot command dot access within the robot controller API namespace. This interface provides the methods for accessing and managing robot commands, sorry. So there here we have get robot command returns the list of robot commands objects. Then get robot command by ID retrieves the specific robot commands by ID. Add robot command, it adds the new robot command object to data store. Then we have update robot command, updates an existing robot command object in data store. Then we have delete robot command. It deletes a robot command object from the data store based on its ID. Basically, this interface serves as a contrast that defines what operations can be performed on robot commands, allowing different implementations to provide actual data access logic. Now we'll just run the code by .NET run, and the code is building here as you can see, and the code is built. Now we'll jump to postman. Here we have the get command, get request, where we get the robot commands. Then we have get robot commands from the moving the robot. This is the output for this. Then we have the get robot command by id. We have an id there, and here's the request for this. Then we have a add a new robot command. Here we'll add a new robot command just by adding the, yeah, we have updated the body here, there, and we added it. Then we have the update an existing robot command. We'll send it. Yeah, it's updated. Then we have delete robot command. Yeah, here you can see that's deleted also. Here we getting all the maps. Yeah, you can see we're getting all the maps. Then we have the getting the maps that are square, like all are square. You can see we have the maps that are square, having each columns and rows equal. Then we have posting a new map. We'll edit the body and post the new map. Yeah, you can see it's updated. So this is, thank you so much.